Alright guys, so if you're watching this video, it's because you need some extra support on our study of star systems and galaxies and Earth and space and time. So to get started with this tutorial, we're going to review lesson 2 right here from our book on star systems and galaxies. And I'm going to ask that as we get started, what I want you to do, if you're a Bell High student and you've been assigned this tutorial, I want you to get out a piece of paper. You can pause the video right here for just a second if you need to, and get out a piece of paper and just kind of follow along by taking a few notes and writing down a little bit of information as we go on some key things that I'm going to show you. And then you're going to do something with that at the end to turn into me as evidence that you've completed this tutorial. So do that right now, and then we'll continue. What I want to do is go to this next page now, and I want to kind of outline some things that 8th grade students have gotten confused when it's been presented to them on an assessment. When it's in the middle of a question, it doesn't seem like this would be that difficult, but I know how it is. Whenever you're looking at those words on a page, it's easy to get things mixed up. So when we start talking about stars and planets, the galaxies and the universe, what I want to do is just sort of start with um, some small things to larger. And right here you will see we're going to look at first a planet. A planet is an object that orbits a star, is large enough to have become rounded by its own gravity, a key aspect of a planet, and has cleared the area of its orbit. Remember in our study, Pluto has not cleared the area of its orbit. That's why it's been declassified. Okay, so that's the smaller of these objects. Now, even smaller than a planet would be what's called a planet satellite, another word for moons. Okay, so many of the planets do have moons. Not all, but many of them do. Okay, so then we go from a planet to what's next, which is a star. A star is larger than a planet, obviously, and we're going to talk about that in a little more detail in just a minute. But a star is a giant ball of gas, it says here, primarily hydrogen and helium, which is undergoing nuclear fusion, and our sun, as it says right here, is an example of a star. Okay, so here we see solar system next. Okay, so a solar system is a even larger group. Okay, this is a star and planets and other objects that revolve around the star. And just have to pardon my circle there, kind of messed up, but you can see that. Okay, and so then from a star we go to the next step, solar system. And then we get to a galaxy right here. Now, a galaxy is a huge group of single stars, star systems, star clusters, dust, and gas, all bound together by gravity. Okay, so a galaxy is much bigger than a solar system, and then bigger than a galaxy is the universe. Okay, so that's smallest to largest. Okay guys, the next thing I want to show you here is from this website here. You can Google Solar System Visualizer and go to this very cool website that we looked at earlier in the year. And what we're looking at here is what is known as the inner planets or the terrestrial planets. All these planets are called the inner planets or terrestrial. They have some common characteristics. They're very rocky, have dense iron cores, and small numbers of moons, if any. You know that Mercury and Venus here don't have moons, so Earth has one and Mars has two satellites, natural satellites it's called, or moons. Okay, and you can zoom out from here too, and you can see as you zoom out, the period of revolution appears to get very fast, but really what's happening is as we zoom out, it is getting fast as compared to these outer planets. Okay, and pretty soon here you're going to see the inner planets look like a blur. Okay, and there it is, the inner planets look like a blur. the amount of time it's taken them to go around the sun is really quick as compared to these outer planets, because they are so far away from the sun, and their period of revolution, or the time it takes them to go around, is so much slower. Here you see Neptune going around the sun. This is a vast and great distance as compared to Earth. Look at Earth in there. Look at it go. I mean, we're going around the sun many, many times by the time it takes Neptune just to go around once, okay? And so we got a good look now at the outer planets, and you can see Jupiter, Saturn, Uranus, and then Neptune, and then the declassified planet Pluto here. Declassified mainly because it has not cleared its orbital path of objects, thereby doesn't fit the definition of a planet. So very cool website. You can also look at natural satellites. Let's take a look at Jupiter, which has the most moons, or the most natural satellites. Look at this mess. This is Jupiter and all of its moons in orbit around it. And it looks like all of the moons here, but when you zoom in, there's even more. See, as you get closer, some other moons appear that when you zoom out, just disappear into one of those blurs. They're orbiting Jupiter so fast as compared to some of these others, okay? Now, what I want to show you next is some galaxies, and if you'll take a look at this internet website, I just image searched a galaxy, and this is an image of the Milky Way here. And a lot of students have a misconception. They think there's the sun, okay, that's our sun, but that's not right at all, okay? Our sun is not even visible. It's somewhere either right here where my mouse is, or maybe here. I'm not 100% on this, but it's I couldn't even point to a dot on this image and say that that's our sun. Okay, so this just shows you that there's billions of stars in this one Milky Way galaxy, and there's many, many billions of galaxies in this vast area of space that we call the universe. Okay, so if I go back to some of our book pages, I wanted to show you something else about galaxies that's important that you need to remember, and you can make a few notes about this. There's 4 types of galaxies, and we just looked at a spiral galaxy. Okay, a spiral galaxy has those pinwheel arms, and that's what the Milky Way is, and we live inside of a spiral galaxy. There's also an elliptical galaxy. Okay, an elliptical galaxy is kind of football shaped. Sometimes you could describe it. They look like round or flattened discs. Okay, all right. Then there's irregular galaxies, which really don't have a defined shape. They are smaller usually than other types of galaxies. The text says here. Okay, and then last, another type of galaxy is quasars. Okay, and a quasar are active young galaxies with huge black holes at the center. Okay, and so there are 4 common types of galaxies there that I wanted to show you. If we go to the next page, it's got a good some good photos of these types. Okay, here you see an elliptical galaxy, kind of football shaped there. An irregular shaped galaxy over here that really doesn't have a defined shape. Okay, this is a quasar here with that huge black hole at the center down here. Okay, all right, and then on the other side of the page, which I don't know if I can show you, well, I can't quite see that right now, but the Milky Way, or a spiral galaxy. Here's a sample of it. It's not quite as pretty of a picture, but we already looked at one earlier, a spiral galaxy. So, again, I need you guys to understand that in space, there is immense distances between not only our planets and our solar system and our sun, but when you start traveling to other stars and other galaxies, it's almost mind-boggling, okay? So a couple of things I want to point out here from this page. Let me go to this different setting here, and we see that, okay, the universe is all of space and everything in it, and it is an enormous, almost beyond imagination, immense size, okay? And it's so, this items or objects, astronomical bodies, are so far apart that scientists use the light year to describe distances between stars, okay? You couldn't use miles or meters or something that we use here on Earth, because we would have such huge numbers that it wouldn't even be practical. So scientists have developed and used this system of, or unit of distance, called the light year, okay, and that is used to measure distance. And light travels at a very quick speed, 300 million meters per second. Okay, and a light year is the distance that light travels in 1 year, about 9.46 trillion kilometers. Okay, so a light year is a unit of distance, not time, remember? And scientists use scientific notation to work with these numbers, and we learned about that in class earlier this year. So let's take a look at this 300 million meters per second. Can you write that in scientific notation? All right, the rules for scientific notation are as follows. You would start with a decimal between the 3 and 0 there. Okay, so it'd be 3.0, and then you times 10. Okay, 3.0 times 10. And then you count the decimal places from the zeros. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. So light moves at a speed of 3.0 times 10 to the 8 meters per second. And that's how you do scientific notation. Okay, let me let you try it again. Take a look at this huge number right here. This is the speed of light, 9.46 trillion kilometers. Okay, this is actually, it says that here, this is 9.46. I guess this wouldn't even be true. Would this be trillion? This is massive number has been converted to meters. Can you write this in scientific notation? Give that a try right now. All right, walk along with me. So it'd be 9.46. Give a point in there. And how many decimal places? 9.46 times 10. Now you can write this on your paper. Okay? And then you count the decimal places. Go ahead and count them right now. So we start right here. We can really do it by threes, can't we? We can go 3, 6, 9, 12, 15. So that written in scientific notation would be 9.46 times 10 to the 15th. Okay, and scientists do that so they don't have to deal with all this huge numbers of zeros when they deal with these big numbers. Okay, but that's how far objects are in space from each other. It's so immense. I mean, to go to the closest star, the nearest star to our sun, and look down here, it's called Alpha Centauri. Alpha Centauri is 4.2 times 10 to the 16th meters away. Okay, and we calculated in class that if you left Earth in a space shuttle, you're going to take a journey to the nearest star, which would be Alpha Centauri. You couldn't even come close to getting there in your lifetime. We calculated it'd take over 100,000 years to get there. Okay, and what I'd like for you to do as you look back at the notes that you've taken as you've watched this tutorial, what I'd like for you to do is just to develop 5 really good practice questions from what you've looked at and what you have on your page. So develop 5 good practice questions and turn that in as evidence that you've completed the tutorial, and I hope this has helped. All right, thanks.